This is Microscope Part 2. Excuse me. Now, in an earlier video, I went over the parts and how to use a microscope. And so what I've done is I have come into our lab and I've taken one of our microscopes that actually can be hooked up to our video camera, and I have it set on the lowest power. And remember, in the previous video I was talking about lung tissue. So what I've done is I've set this video up, I have it on low power, and I'm now going to bring this into focus using our coarse adjustment. And if you'll watch, oh my gosh, something is coming onto the screen. Now, here are some issues with using a microscope. If you notice right there, let me see if I can get out of this chair and I can show you exactly what I'm looking at. There are some issues with using prepared microscope slides. You'll notice streaks or spots. Please don't think that's what you're looking at. As you're bringing the slide into focus, these are actually defects. This up here in the top. These are actually defects in the tape over the sample. I had several students on their microscope lab who drew me pictures of dots, telling me that this was their sample that they were looking at. And as you can see, there's a big one right there. These are defects in the tape, and this is a problem with older slides, is that we have a lot of defects. These could be they've been stacked too long, they've been mishandled, something's been going on. So as you can see, there's a lot of those little dots on there. So I'm going to find a part of this slide that looks pretty decent right in there, and we'll just use this section of the slide for what we're looking at. So I'm going to continue to bring this into focus. I want you to watch as the defects go out of focus and we get more in focus on the tissue sample that we're looking at. Yes, we can still see the defect in the tape. Now, this is under low power. This is that lung tissue that I was telling you about in the earlier video. I'm now going to rotate this to medium power. As you can see, it's now out of focus again. So I'm going to use the fine focus, the fine adjustment, and I'm going to bring this back into focus. Now, if I understand this sample correctly, the large white areas that you see, these are the openings in your lung for air to pass through. Think of your lung like a couple of sponges in your chest. And in the tissue areas, those are the blood vessels, brings the blood to the cavities so that the air molecules, the oxygen molecules, can be exchanged for the carbon dioxide that you're breathing out. I believe very simplistically that's what we're looking at here. I'm now going to rotate to high power. Now, as I was saying, need to be very careful. I am watching this as I bring this over. There we go. Now, students were asking about the white spots that you see. These are defects in the video camera itself. Please do not be alarmed. So I'm now going to bring this into focus even more. You'll notice the more magnification we get, the harder it is to see detail. And on this one, I'm going to adjust my light on the diaphragm. I'm going to see if I can focus that light a little bit. Brings out a little bit more detail, but again, too much light could bleach this out completely and get us to where we cannot see anything. So this is about the best detail, the best viewing we have on this particular sample. I have one more lens on this particular microscope, a highest lens, and I believe, there we go, I can bring this now into focus and we can actually see. And again, too much of anything is sometimes not a good thing, because that is about as in focus as I can get this, because I'm actually looking through it, and right there is about as well as we can see this sample. So sometimes having too much magnification doesn't help us at all. Alright, so that's our lung tissue. So that's one of the procedures. So let me just take you through a few more slides. Always rotate out to the low power. There's our low power again. Let me bring that back into focus. There we go. Alright, I'm going to take the lung tissue out, being very careful when I set it down. I also have some pancreas. Now, me personally, pancreas is very near and dear to my heart, but that's as far as I'll go on that one. And we're going to center this. Let me get that centered a little better. Alright, and as we said, here again, what you're looking at, all those spots are defects in the tape or the cover slip over the sample. So please don't think that that sometimes is what you're looking at. Now, I can focus on those really well. So I'm going to go ahead and draw it into focus. There's some more defects. And I went too far, so let me back it out, and wow, where's my pancreas? Okay, let me see about moving this around. And there's the edge of, that's the edge of the cover slip. So let me come back and let me turn down the light. That will help, I'm sure. And then let me reposition this. There we go. And let's try this one more time and see if we can get that into focus. And obviously Mr. Pancreas is not going to work with us, and he's been working with us on all the other microscopes, and he's just not going to work with us on this one. Interesting. Okay, let me go to one more power up, and let's just see if we can't find him under here. And I see something. Hang on just a sec. There we go. Pancreas. Your pancreas in your body is located just right behind your stomach. It's actually attached to your backbone. And your pancreas is responsible for providing enzymes that help you in your digestion. Your pancreas is what is called a soft organ. If you were to feel it, it would probably feel about like Jello. So it's a very soft organ. It also makes it very difficult. There we go, I got that a little bit better. Makes it also very difficult to work on because of its texture. It's kind of like brain tissue. And people get pancreatic cancers and that kind of thing. It's very, very difficult. Pancreas also produces insulin. So it's very important. People that are diabetic, you need to take care of your pancreas. In my case, I've had some issues with my pancreas in the past, and so I try very hard to monitor what I eat and what I'm taking in so that it's going to function for a few more years anyway. So, a little bit of pancreas. I'm going to rotate this back to low power. There it was. We just couldn't find it there. That's under low power. So, Again, sometimes it takes a few minutes to find what you're looking at in the sample. We'll set that one down. Now, here's where this whole scientific part started with the microscope. Back in the 1600s, the scientist was looking at a sample of cork. Hook, wasn't it? Was it Hook that was doing this? I know I teach biology and I don't even know who looked at the cork. It's alright. But it was a sample of cork, and again, cork comes from the cork tree, and under a primitive microscope, this was what the scientist saw. And he called those openings cells because he reminded him of the sleeping chambers that the monks would have in a monastery, which were called cells. They were very tiny. And as we look in a little bit closer, you can see that these cells come in different shapes and sizes. Some of them appear to be empty. Some of them appear to have something in them. We can adjust the light a little bit and get a little bit better view. And let's go even closer, shall we? And see it. Whoa, see what we can see here. And again, too much magnification, I can bring the top part into focus. I can focus all the way through to the bottom. So let me find that happy medium. We'll adjust our light and see if adjusting the light helps a little bit. Focusing the light in there. There we go. So as you can see, there's where cells come from cork. And then finally, the one that provided the most headaches to my students in this lab, I asked them to look for, let me reset that to low power. I asked them to look at human blood. What you're actually looking at, I think down towards the bottom you can see the defects in the cover slip, but those dots, what looks like just a smear, that is human blood cells. If I up the power and bring this into focus, those, ladies and gentlemen, are human blood cells. They look like little donuts. They're called platelets. They're called platelets because they're flat. Let me see if I can get this a little better here. There we go. Now let me adjust the light. See if we can't focus our light a little better. There we are. Alright, those are human blood cells. And in the original there were several thousand. Here there's maybe a couple of hundred. All of them are about the same shape and size. Some of them look white in the middle. Some of them are dark in the middle. I believe that has to do with who's hauling oxygen and who's not. Also, I think there's white blood cells in there at some point. I'm not sure. Anatomy and physiology is not my specialty, although we have teachers that teach it here. But in this case, what we would normally be looking at is we'd be looking at, are they the same shape and size? Do they appear to be the same? You'll see some that look to be linked up, but they're actually overlapping each other in the sample. Let's go one more power up and just see if we can't bring this into focus. And yes, we can. Just like that. Let me adjust our lighting a little bit. See if the lighting helps. There we go. And that is, oh, it looks better on the camera than it does to my eyes. But that is about as good as we can get looking at human blood cells. And again, we're using a older video camera that the school has had for a while. I'm playing with the diaphragm settings on here to see if we can't get a little bit better view. And that's about as good as it's going to get right there. So, ooh. right there. Alright, so we've taken the time to learn about the parts of the microscope. We've taken the time to learn the basic use of the microscope. I've now shown you some slides under a microscope to show you some of the common things to look out for as you're looking at samples under a microscope. You heard me, there were things that went right, there were things that went wrong. But the objective of the exercise is always to attempt it, to ask questions if you're not getting it, because we don't learn anything unless we ask those questions. Alright, I'm going to go now and upload this, and stay tuned for the conclusion of the osmosis and diffusion lab. That's coming Monday, as well as the what happened after the lab with those eggs that we had in the vinegar water, the distilled water, and the sugar syrup. It's going to be exciting. Check those segments. I'm sure at some point I've already uploaded them, actually, as opposed to here I am making this video and waiting to upload them day after tomorrow. Alright, thank you for watching. If you have any questions, send me a message at YouTube. If I can respond, I will. I've been known to a couple of times go live and do a live segment where I'm on and responding to some of your comments. Thank you very much.